In this video for section 15.2, we're going to talk about how we can add a qualitative variable to a linear regression model. So in example 15.1, we wrote a linear regression equation to predict the sales price of a house based on 5 independent variables, and these were all quantitative variables or numbers with units: home size, age of the house, number of bedrooms, number of bathrooms, and garage size. So what do we do if we want to consider the effect of a variable that is qualitative? For example, whether the house is located in a specific neighborhood or not, or whether the house has air conditioning or not. Those are things that could affect the sales price. The way that we do this is using what's called a dummy variable or indicator variable. So in this case, I'm going to set my dummy variable to be x6 because I have my 5 other variables that I've already used. That variable is going to equal 1 if the house is located in the neighborhood, the foothills. It's going to equal 0 if the house is not located in the foothills. It doesn't matter which one is 1 and which one is 0. I could set 0 to be located in the neighborhood and 1 to be not located in the neighborhood. I just have to remember which is which. So we're going to continue our First City real estate problem here. They've added the neighborhood variable to their spreadsheet, and they've added the information about whether each property is located in the foothills or not. So we're going to find the new regression equation, test it for significance, and test each slope coefficient for significance. Then we're going to compare the r-squared value, the coefficient of determination, to that of the original model to see if the new model is better. We are also going to use our new model to predict the price of a home. So we're going to go to our spreadsheet here. This is in Blackboard as usual, and you can see that we've added a new column since the last time we used this for neighborhood. And we have 1s for the homes that are located in the neighborhood, the foothills, and 0 for the homes that are not. So what we are going to do is we're going to go to Stat, Regression, Regression again, and Fit Regression Model. This is the same window that we used in the last section. Our responses variable is still going to be price because that's what we want to be able to predict. And our continuous predictors, we're going to put all the quantitative variables. So these are the same ones that we had before. Again, I'm going to put them in order here. And in the categorical predictors box, that's where I put the variable that I have categorized with the 0s and 1s, or the dummy variable. So neighborhood is going to go in that categorical predictors box. Now I need to click on a box down here that I'm not sure you can see, but it says results. There isn't really a good way to move this, but I'm going to click on the box that says results. And then what I need to do is in this box that says regression equation, I leave that checked, but I change the drop-down menu to single equation. Then I click OK and click OK again. So here are my results. I have my regression equation here. The way that Minitab does the regression equations is it's going to put a 0 times whichever one you have entered as 0. So you're just going to ignore that in your equation. But I have the rest of my new regression equation here. Notice that the slope coefficient of neighborhood 1 is 62,041. So what that's telling us is that the houses in the neighborhood are going to sell for a price on average that is $62,000 more than they would if they were not in the neighborhood. So we have our coefficients here. And then we have our model summary and analysis of variance boxes. So we'll start with the overall model. We see that our F value is 487.65 with a p-value of 0.000. So I'm going to write for number 1 here. My F value is 487.65. P-value of 0.000. So this tells me that I am rejecting the null hypothesis and the model is significant. So now let's look at my individual slopes. So if I go up here to the coefficients table, I see my t-values here for each, the square feet, the age, number of bedrooms, number of bathrooms, garage size, and neighborhood. So I would put those t-values in when the homework question's asked, and then look at my p-values to determine if they're significant or not. So I see p-values of 0 here for all of them except for this one. Bathrooms has a p-value of 0.420. And what that means is that it is not significant. So I am failing to reject the null hypothesis because the p-value is not less than alpha there. So what does that tell me? Well, that tells me that I should remove it from my model before I use the model for predicting. So to remove it from my model, what I do is I run the calculation again, go to regression, regression, fit regression model, and I can simply take that out of the continuous predictors box. Then I click OK. And so here is my new model that does not use bathrooms in my equation. So it is not significant and should be removed. So now we're going to look at the coefficient of determination, or the R-squared value. So I find that, going down to the model summary box, the R-squared value is 90.34%. Or if I'm entering that as a decimal, it would be 0.9034. So, is this a better model? Yes, because the R-squared value is higher. So remember that this is the percent of variation that is predicted by the variables in the model. So I went from 81% to adding the variable of neighborhood, raised that up to 90%. So I'm predicting 90% of the variation in home prices. So we'll say yes. The new model is better. And then question 3 is asking us to predict the price of a home. So in order to predict the price of a home, we need to write down our equation. So I'm going to copy it down here from the Minitab output. Remember that the coefficients, if I needed more decimal points here, I can get those by clicking on the coefficients box and changing the decimal places. In this case, I'm just going to use what they gave me. So we have negative 7,050. That's my constant, plus 6249 times number of square feet. So that's telling me 6249 per square foot is added to the price of the home. Minus 322.0 times age. Minus 8830 times number of bedrooms. plus 26,054 times garage size. And then ignore this 0 times neighborhood 0. If neighborhood value is 0, then it's 0. Plus 61,370 times neighborhood. So that's whether the house is in the neighborhood or not. So remember, we said that 0 was if it was not in the neighborhood. So I'd plug in 0 if it was not, and that would just be nothing. I would plug in 1 if it is in the neighborhood. So what I'm plugging in here is 1,800 for square feet. So this is going to be price equals negative 7,050 plus 6,249 times 1,800 for square feet minus 322 times age, which is 10. Yep, the house is 10 years old. Minus 8,830 times number of bedrooms, which was 3. And plus 26,054 times garage size, which was a 1-car garage. Notice we did not use the number of bathrooms in our model because we took that out. And then plus 61,370 times neighborhood. We said that it is located in the foothills, and going all the way back up to here, if the house is located in the foothills, then that variable equals 1. So I'm multiplying that by 1. So type this all into your calculator and you can get a predicted price for the home of $163,146. So predicting is just about plugging the numbers into your model for whatever the home or whatever it is that you want to predict, plugging the numbers in for the x variables and doing the calculation and then getting the y variable. That's all predicting is.